Welcome to Bin 95 Siemens and Factory I/O Open Production Line Example and Exercise. Factory I/O simulation software allows users to build and test open production lines. The factory simulation software uses modular machines and equipment. It allows for different parts, colors, etc. Users can switch between products or production types. This lesson will use the WinSPS S7 Siemens PLC simulation software for automation control. We will take a look under the hood later in this video. Like in PLC programming and troubleshooting, we will first get familiar with the open production line example system and operation. This production line makes bases and lids using two machining centers. The automation control comprises a Siemens S7-300, a mainline control panel, and two machining center control panels. The operator presses the run button, the line switches to auto mode. There are counters for each. And cell 1 starts producing bases, and cell 2 lids. The stop button removes the line from auto mode. No new raw material enters the cells. The cells finish their work in progress and then stop. Before we added automation to make this line an open production line, running a batch in one cell required the whole line to be shut down. Closed production lines are inflexible. In this new version you will download, operators can place any cell in batch mode or stop if there is an issue while the rest of the cells in the production line continue to run. Also, while updating the PLC logic, we found there needed to be an indicator on the remote system control panel to let operators know one of the cells has an issue or that a cell is offline running a special batch of products. On the main system control panel, the yellow light for each cell will blink if the cell cycle time is longer than expected. It will be solid yellow if the operator places the cell in batch mode. Also, the reset button resets the counters on the main control panel. The stop button on individual cell control panels stops the robot. The start button will allow the robot and machining center to continue where it left off. The cell reset button will eject the part regardless of whether it is finished or not, making the cell ready to produce new parts. The green auto lamp on cell control panels lets the operator know the entire line is currently in auto mode. All control panels have indicators from other panels. Open production lines may be reconfigured to make each cell or control panel no longer visible at all locations. Thus, there is a need for status indicators on remote control panels. Let's explore the programming behind the open production line automation control. For this exercise, we use Siemens S7-300 PLC programming language. The PLC simulator used is the WinSPS S7, also referred to as WinPLC 7. While this is an old Siemens PLC simulator and processor, it gets the job done. Not every machine you run into in manufacturing has the newest PLCs and software. Many will be older versions that are still doing the job. Let's take a tour of the ladder logic controlling this. We will skip over the rungs covered previously in the beginner lesson. We must focus on our changes to convert to an open line with educational tidbits added. After watching this video, the best approach is to download the project from the lesson page and study the code. The best practice is to use standard industry naming conventions and tags instead of addresses as much as possible. So we changed the run tag to auto and replaced addresses with tags. Also, each rung with a descriptive rung comment is best practice. As this PLC simulator software does not support that feature, we at least add network comments to help others read through the program. We added a rung for the auto lamps on each control panel. The most common rung layout for multiple outputs is branching outputs. In-series outputs like the rung above are more difficult to read by others. In Network 2, we added only count products if the cell is not in batch mode. The beginner's lesson covers the other networks, timers, etc. Network 7 is a new one with all newly added ladder logic. The first two rungs of Network 7 are an example of creating a 1-second pulse if your PLC brand does not already have a more efficient 1-second pulse bit, like the one the Allen Bradley PLC brand has. The following two rungs monitor whether either production cell has work in progress, also called WIP. The remaining 4 rungs of ladder logic in Network 10 monitor the cycle time of each production cell. They are the logic behind the indicator to monitor the remote system control panel. This is to let the operators know one of the cells has an issue, or that a cell is offline running a special batch of products. On a final note, time permitting, students should change the wording of tags and control panel labels from lids and bases to cell 1 and cell 2. Product types and names can constantly change because this is an open production line. Lids and bases will make no sense if you run rings and pinions on one shift. We hope you found this Siemens Factory I/O Open Production Line example video helpful. The free online PLC programming lesson is at bin95.com. On that lesson page you can find links to download the Factory I/O factory simulation software, the WinSPS S7 Siemens PLC simulation software, and the Open Production Line project downloads. Please comment and ask any questions in the YouTube comment area. Your interest will encourage us to create an expanded project version using the latest Allen Bradley processor and Rockwell software.